Good day, everyone. For this video, we'll be discussing about the chemical properties of fuels. So the first chemical property is our carbon content. The carbon content in fuel signifies the amount of carbon atoms present. It directly influences the energy content of the fuel, as carbon is a key component in combustion reactions. So we have here different fuels with their calorific value and their carbon content. As you can see, based on this particular table, our carbon content for Coke is 29.2 and it has a lower calorific value of 28,435 kilojoules per kilogram, followed by our washed coal, which is 26.2 kilogram per gigajoule, and its lower calorific value is 26,344, and so on and so forth. Next would be your hydrogen content. Hydrogen content in fuel is pivotal for combustion efficiency, influencing the balance of carbon and hydrogen in the process. If carbon is more on energy, hydrogen is more on environmental protection. Higher hydrogen proportion enhances combustion efficiency, contributing to a cleaner and more complete burning, ultimately impacting overall engine performance and emissions. So again, carbon is for energy, hydrogen is for combustion efficiency, particularly producing a cleaner and more complete burning. So these are the different illustration of wood, coal, oil, natural gas, and hydrogen based on their carbon content and their hydrogen content. So as you can see, for wood, it's more on carbon, less on hydrogen. Coal, oil, natural gas is more on hydrogen and less on carbon. And hydrogen, of course, contains hydrogen only and no carbon at all. Achieving an optimal ratio between carbon and hydrogen is crucial for marine engines, ensuring both efficiency and reduced environmental impact. So we kept on mentioning this one. Carbon is for energy output, hydrogen is more on environmental protection with good efficiency and at the same time reduced pollution. Next would be our sulfur content. Sulfur in the fuel is one of the main factors for sulfur oxide pollution from ships, a pollutant which is currently under major scrutiny. So as per MARPOL, the current sulfur value for HFO or heavy fuel oil are in the range of 3.5% on a on and after 1 of January 2012. But currently, we now have 0.5% per weight on and after January 20 or January 1, 2020. So this is our new standard for sulfur content of our fuel. It should only be ranging from 0 to 0.5% as a maximum. But during the past, we have 3.5%, but it was now limited to 0.5%. So higher sulfur content contributes to sulfur oxide emissions, necessitating careful consideration due to environmental regulations. Take note that once you burn a fuel with sulfur content, it will be converted into SOx like SO3 and SO2. And when these gases, sulfur dioxide and sulfur trioxide, combined with water in the air, and once it precipitates with nitric acid, you will have your acid rain, which is also very detrimental not only to the ship but also at the same time to the water or to the sea or ocean acidification. So these are the beneficial changes from IMO sulfur limit for ships fuel oil. So we will produce cleaner air, positive impacts on human health because there's less sulfur that we could inhale from the process, higher quality fuels, of course. Ship operators, owners, and refineries have adapted to it, and changes for enforcement authorities. Next to the water content. Water in fuel leads to a disease, or I mean to a decrease in the efficiency of fuel oil and leads to energy loss. So instead of burning fuel, then we will try to burn water, which is producing a bad effect on our combustion operation. Heavy fuel oil mixed with water, if burned, will lead to corrosion of internal parts. As we all know, water is very corrosive at times, especially once it comes into contact with a metal after a long period of time. How much more seawater contamination? Oxygen content. This refers to the amount of oxygen present in a fuel substance. Oxygen content is a crucial factor in combustion processes where fuels react with oxygen to release energy. It is often expressed as a percentage of the total weight or volume of the fuel. So the oxygen content of fuel affects combustion efficiency, just like your hydrogen content. An optimal oxygen level can enhance the combustion process, leading to improved fuel efficiency and reduced emissions in marine engines. Next, we have the numbers, the setting number and your octane number. Setting index, this is applied for diesel. Setting number is a measure of diesel fuel ignition delay, which can alternatively be described as the time between the commencement of fuel injection into the cylinder and the first discernible pressure increase during fuel burning. So in this case, the higher the setting number, the shorter the ignition delay, and the lower the setting number, the longer the ignition delay. So as much as possible, in this case, we need to have for diesel higher setting number so there will be no ignition delay in our process, which could lead to a malfunction in our combustion chambers. Next is the octane number. This is for gasoline. The octane number is a measure of a gasoline's resistance to knocking or detonation in a spark ignition engine. So higher octane numbers indicate greater resistance to knocking, which we would like, which is essential for high performance and efficient gasoline engines. Meaning, once we have higher octane number, there is more chance or greater resistance to knocking, while lower octane number means lower resistance to knocking. But as what we need to have higher octane and at the same time higher setting number in order for us to have better quality of combustion with minimal delays in the operation. Next would be aromatic and aliphatic content. Aromatic compounds have a cyclic structure, while aliphatic compounds have an open chain structure. Just like this one, like the benzene ring, it is aromatic since it is ring shaped or ring like, and we have the aliphatic, which is straight chain or branched type of organic compound, just like your methane. The balance between these compounds influences fuel stability, combustion efficiency, and engine deposits. And we also have here your acid number or AN. We also oftentimes call this one as your TAN or your total acid number. Acid number has been included in the standards to take into account any potential damage to marine diesel engines, primarily fuel injection equipment due to acidic nature of fuel. Take note, acidic. So this is associated with corrosion. Testing for AN can give indication of the presence of acidic compounds. It should always be kept in mind in the event of an AN or acid number exceeding limits. It may still be fit for purpose depending on nature of the acid. But as much as possible, if your TBN is now lesser than your acid number, we need to change our oil in order to maintain safe operation and the longer life of our machineries, especially in terms of corrosion protection. So again, acid number is associated with corrosion. And the last chemical property of fuel would be our distillation characteristics. Reveal the temperature range over which the fuel transitions from liquid to vapor. This is crucial for ensuring proper combustion, meaning our fuel has been vaporized in this particular process before ignition, preventing engine deposits and avoiding issues related to incomplete vaporization, which may cause problem in our operation. That's it for our chemical properties, and I hope you learned something for today's video. See you in our next video. Bye-bye.